must have been in grade 5 or 6 when a certain mathematics teacher of mine introduced us to an idea that was probably the first mathematics idea to actually blow my mind. So, what is this idea? Alright, I'll tell you. But first, let's brush up on some definitions because they're important here. Okay, polygons. What are polygons? So roughly speaking, you can think of polygons as just shapes, the shapes that you know and love. We're talking triangles, squares, rectangles, octagons, hexagons, you name them. But there's a little kicker here. Not all shapes are actually polygons. For example, a circle. A circle is a shape but is not a polygon. Why? Let's try to give a concrete description or definition of what a polygon actually is. A polygon is a shape that is made up of at least 3 lines and angles. 3 lines and angles, at least that number. So now we can already see that our circle, is already outside of the window because, a circle does not have 3 straight lines or angles or more than that. Alright, now that we have that out of the way, there's one definition left before we get to the main idea. Polygons are boring. They are flat, they're in 2 dimensions. We don't want that. We want something more interesting. So we blow up these polygons into 3 dimensions. What I mean there is we take these polygons, say we take triangles, we join them together to form something more, more in the real world, something we can interact with. So you know what comes up. We have cubes, or what you can think of as a box. We have tetrahedrons, which is nothing but this 3-dimensional shape that has 4 sides. We have octahedrons, which is nothing but a 3-dimensional shape with 8 sides, and so on and so on. We also have like an icosahedron, which is the typical shape in which the genetic material of viruses is actually contained, which is this 3-dimensional shape with 20 faces, right? And these are called polyhedrons, and polyhedrons have important properties, right? We'll talk about 3 important properties here. They have vertices, they have edges, and they have faces. We'll start with faces. Faces are intuitive. That's easy to understand. We all know faces. These are just sides, right? And then we have edges. What are edges? Edges are just nothing but the lines, at which 2 faces, meet. Now you have one face, put it together with another face, join them with glue, and the line along which these 2 faces join is called an edge. And now the third property is a vertex. This is a vertex. Informally, you can think of a vertex as nothing but a corner. Now make sure that you understand those 3 properties: faces, vertices, and edges. Now, here's the idea. If you take any of these polyhedrons, say you take the 4-sided tetrahedron, or you take the 5-sided triangular prism, or you take the 6-sided box, or cube, or you take the 8-sided octahedron, or whatever you take, right? Whichever polyhedron you take, if you count the number of vertices, you subtract the number of edges, and then you add the number of faces, you will always get the number 2, right? And, as a practical example, let's take the box or the cube, right? Now, this box in front of us has 8 vertices, 12 edges, and 6 faces, right? Make sure you can get that. It's 8 vertices, 12 edges, and 6 faces. So then we have 8 vertices minus 12 edges, which is -4, plus 6 faces. Now that's 6 minus 4, which is equal to 2. And I think that's quite neat, because it applies for all these polyhedrons. And I think that's so nice and neat. And, things didn't have to be this way. Things didn't have to turn out so nicely, but they do. And this is attributed to the Swiss mathematician Leonhard Euler, and it goes in some circles as Euler's number, or Euler's formula, or Euler's characteristic more generally. And I'll leave you to satisfy yourself with other polyhedrons, that this is indeed the case.